For number one, what type of function is this? You would simply graph it on your calculator, and you would have these notes on your note card, and you would have to pick out which one it is. And when you graph it on your calculator, you're going to get a smooth curve going up, just like the exponential graph right here. So the answer to number one is exponential. Number two, we are trying to figure out what is the independent and dependent quantities. Well, our independent is on the x-axis, so we would say our independent is time in minutes, and our dependent is the y-axis, which is the distance in miles. Now these notes over here on the left-hand side, you may want to include on your note card as well. Number three, which best describes the behavior of this function? Well, you would graph this on your graphing calculator, and it would look something like what's on the right of the screen. And you have to figure out, is it constant, increasing, decreasing, or both increasing and decreasing? And if you remember, we read a line like we read a book. We start on the left side, and we go to the right. And if we go from left to right, it is going down, and down means decreasing. Number four, which statement about this function is true? So we would again graph this on our graphing calculator, and it's going to look something like what's on the right of your screen right now. We need to figure out, does it have an absolute minimum, maximum, does it have both or neither? A minimum means the lowest point, and since this graph is going down, I cannot find the lowest point. But I can find the highest point, which is this blue point right here. And the highest point is called the maximum. So this graph does have a maximum. So our answer is B. Number five is a similar problem. Number four, again, we would just graph this on our graphing calculator, and we have to figure out, does this have a highest point or a lowest point? And again, this blue dot represents the highest point, and the highest point is called a maximum. So this one has a maximum as well. Number six, what is the classification of this function? So again, we would graph this on our graphing calculator. I would use the notes that I had for number one, and I would figure out which one does it look like. And when I graph this on my graphing calculator, I would find that it is a curve that looks like a U, and that is a quadratic. Number seven, which graph represents a function? Now remember, this is a vertical line test. So if I can draw a vertical line and only hit once, it is a function. But if it hits twice, it is not a function. So if I start with A, I draw a vertical line and hits once at the first dot, twice, 3 times, 4 times, and 5 times. So A is not a function. It hit 5 times. On B, if I can draw a line anywhere straight up and down and it hits twice, well, it hits once right here and hits twice. So it hit twice, so therefore it is not a function either. So our answer is not B. Part C down here, if I can draw a vertical line here, it hits once, twice, so part C is not a function either. Now on part D, if I draw a vertical line here, it hits once, and if I draw it anywhere, it's only going to hit once every time I draw a vertical line. So D is my answer. Number 8 is extremely similar to number 2, where I'm asking you for both the independent and the dependent quantities, and these notes over here on the left side of your screen are what you'd want to have on your note card. Now on numbers 2 and 8, I'm asking you for both the independent and dependent, but on the actual test, question 2 might ask you about one of them, and question 8 might ask you about the other one to make sure that you know. So on this one, the independent is the x-axis, and again our independent is time in hours. And the dependent is the y-axis, and this one is distance in miles. So make sure you understand the dependent and independent variables. Number 9, describe the pattern below in sentence form. Again, on the test, this is going to be a multiple choice question, and I went ahead and wrote the number underneath the blocks. The first one is 3, then 6, 9, and 12. It looks to me like they are adding 3 every time, which would make this an arithmetic sequence because it is adding or subtracting. Number 10, write the explicit formula that represents this situation. Well, this is an arithmetic sequence because they're adding 4 every time, so I went ahead and wrote the arithmetic explicit formula in blue. So we need to write this now with these numbers. So a sub n equals, a sub 1 is my first term, and my first term is -5. They're adding 4 every time, so my common difference is +4, and then I bring down my n minus 1. So what's written in red is my answer. Number 11, determine the sequence. Is it arithmetic or geometric? And then identify the next term in this sequence. Well, to go from 4 to 12, it looks like they're multiplying by 3, and then from 12 to 36, they are multiplying by 3. So it is geometric because they are multiplying. They are multiplying by 3. And then the next term in this sequence, so I would just take 36 times 3, and I get 108. Number 12, what is the 10th term of this arithmetic sequence? Well, I just need to plug in a 10. So a sub 10, which would be the 10th term, would be 6 plus 1/3 parentheses, but instead of n minus 1, I'm going to plug in 10 minus 1. And when I type that into my calculator, I get that the 10th term will be 9. Number 13, what is the common ratio of this sequence? And if it's going from positive 81 to negative 27 to positive 9 to negative 3, that means they're multiplying by a negative number to get it to switch from positive and negative. So the common ratio has to be negative. Now, it appears that they're dividing by 3, but we're not allowed to say dividing. So we have to figure out a loophole around that. And they are multiplying by a negative, and the opposite of dividing by 3 is, or not the opposite, the exact same thing would be to multiply by 1/3. So the common ratio is they are multiplying by a negative 1/3. Number 14, determine if this is arithmetic or geometric, and then give the next term. To go from negative 10 to negative 16, negative 22, negative 28, they are subtracting 6 every time, and adding and subtracting is arithmetic. The common difference would be negative 6 since they are subtracting, and if I keep on subtracting, I would get that the next term would be a negative 34. Number 15, she is recording the cells in a dish, and after each hour, the cells divide into 2 cells. The sequence is shown below. 1, 2, 4, 8, 16, and 32, and it looks like they are multiplying by 2 every time, and as soon as we say multiplying, that means it is geometric. I went ahead and wrote my geometric formula down here in blue. So now to write this sequence, I'm just going to plug in the correct numbers. So G sub n equals G sub 1 is the first term, 1, and they are multiplying by 2 every time, so my common ratio is 2, and then I have to keep the raised to the n minus 1 power. Number 16, we are trying to write the explicit formula for this situation, and it starts at 150, and it looks like they're adding 5 every time, which would make it arithmetic, and I went ahead and wrote the arithmetic formula in blue. So a sub n equals a sub 1 is 150. It starts at 150. The common difference is they're adding 5, so I'm going to put plus 5, and then also bring down my n minus 1. So what's in red is our explicit formula for the arithmetic sequence. Number 17, which graph most clearly shows a positive correlation? So we're looking for the graph that if I were to draw a line of best fit, it would be going up. And if I look down at C, if I drew a line of best fit, it might look something like this, and it is going up. So therefore, C has a positive correlation. Number 18, we are trying to use the linear regression equation to find how many balloons for week 5. So that means we just plug a 5 in for our x. So on our calculator, we would type in negative 3.2, but instead of times x, it'd be times 5, plus 21.5, and that equals 6. Number 19, the table shows Savannah's salary over the different years, and it says we need to find the linear regression equation based on a number of years since 2000. Now this means at the year 2000 is actually year 0, the starting year. This would be 1 year later, 2 years later, and 3 years later. Now I wrote the steps on your to take on your calculator down here in blue. You may want to include that on your note card in case you cannot remember these steps. So step number 1, we hit stat on our calculator. We click enter for edit, and we type in our numbers. And the year goes under list 1, and the salary goes under list 2. Once we get those numbers typed in, we hit stat again. We click right once to go over to the calculator tab. Choose option 4, which is linear regressions. And depending on your software, with mine, I always had to go down to calculate and hit enter, and then my answer would pop up. Now, the A value, which is your slope, should be 1,750. And your b value, which is your y-intercept, should be a positive 40,500. So what's written in red is your linear regression equation. Number 20, again, we need to find the linear regression equation. The same steps we used on number 19, so those steps you can use for 19 and 20 and 21, and it looks like for number 22 also. So number 20, once I type in all that information, go over to stat and run my linear regression equation, I should get a linear regression equation of y equals 20.77x minus 35. Now, that is not my answer because they're not asking for the linear regression equation. They're asking me to use it to see how many there would be after 20 hours. So I need to type in 20 for my x. So 20.77 times 20 minus 35. And once I type that in, I should get an answer of around 380.4, I believe. Number 21, again, we're going to use the same steps to get the linear regression equation, and once I hit stat and type in all my numbers, I should get an answer of y equals, the slope is 0.18x plus 1.4. Number 22, now this is asking for the correlation coefficient, and if you remember, that's the r value. So we do the same steps we did before, except we don't look at the a or the b value or the r squared value. We look all the way to the bottom where it says r equals, and this time it should be 0.966. Number 23, what is the value of this equation at x equals negative 6.2? So since x is negative 6.2, I'm going to plug in negative 6.2 in for my x. And when I type it in on my calculator and hit enter, I get negative 126.94. Number 24, the gasoline costs $3.95 per gallon. Which graph correctly shows the number of gallons bought for $7.90? So if I look with part A, I'm going to zoom in. For 0 gallons, the price is 0. And if I keep going, it looks like it has a slope of going up $3.95 per gallon. Now the other part of this is when I want to find when $7.80. So if I go to the y column, if right here is $10, $7.80 would be about right here, which gives us this line going across. So the line in red is my gallons. The line in purple, the line in red is your cost, and the line in purple is your gallons, and right here where they intersect is how much or how many gallons you could get for $7.95. So the correct answer is A. Number 25, write the explicit formula arithmetic sequence in function form. Now remember, this is 2 steps. So step number 1 is the distributive property. So I'm going to bring 25 down. 4 times n is a positive 4n or 4x. 4 times negative 1 is a negative 4. And from here, we always combine like terms. And I see like terms in positive 25 and negative 4. So I bring my 4x down, and 25 minus 4 is a positive 21. So this is my function form equation. Number 26, the exact same thing. First step is to do the distributive property. So negative 7 times n is negative 7n or negative 7x. Negative 7 times negative 1 is a positive 7. So when I bring it down, I have to combine like terms, and I'm going to change that to a negative 7x now. And our like terms are positive 3 and positive 7, which gives me a positive 10. So this is my equation in function form. Number 27, the average rate of change, otherwise known as the slope. From negative 8 to negative 4, it went up 4, went up 4, went up 4. Over here on the x side, it goes up 2, and up 2. So every time it looks like it's 4 over 2, which is 2. And I get the same slope every single time, which means it's linear, and my slope is actually 2. Number 28, we need to find 2 points on this graph to find the slope, and it can be any 2 points you want as long as it's crossing perfectly on the grid. And I'm going to choose the y-intercept, and if I look, it crosses perfectly on this other point right here. Now, to go from this first point, it looks like it's going down 1 and to the right 1. So down 1 is represented by a -1, and to the right 1 is represented by a +1. And then I always simplify my fraction. -1 divided by 1 is a slope of -1. Number 29, what is the average rate of change for this equation? Well, I have to simplify this equation first, and then I should be able to look at it and get my average rate of change. First thing I would do is the distributive property. 3 times -4 is -12x. And 3 times 2 is +6. So that means the 6 is my y-intercept, but the -12 is my slope. So -12 is my slope or rate of change. Number 30, Miguel has started running. He runs 3 miles his first week. His goal is to run 1 mile farther than his distance for the previous week. So his second week, he would have 4 miles. Next week, 5 miles. 6 miles, 7 miles, and so on. Now, this sequence looks arithmetic to me because they're adding 1 every time. And since it's arithmetic, I'm going to use the arithmetic formula, which I'm writing in blue. Once I have that arithmetic formula, I simply plug in my numbers. A sub 1 is 3. He's adding 1 mile every day, or every week, and then I bring down my n minus 1. So this is my formula for the arithmetic sequence given. Number 31, I need to write the linear function, which would be y equals mx plus b. I need the slope and the y-intercept. So I'm going to look over here and find the slope first. From 5 to 3, it went down 2. From -1 to 0, it went up 1. Down 2, up 1, down 2, and up 1. So this means -2 over 1 is my slope every time, which reduces to -2. So I'm going to plug that in my equation. So it's y equals 2x plus b. Now I need to get my y-intercept, the b value. To do that, I can pick any point I want that looks easier to me, and there's 4 points over here. I think 0, 3 looks the easiest, so I'm going to plug that into this equation. So instead of a y, it's 3. Instead of an x, it's 0. And now I'm going to simplify it, and it'll give me the y-intercept. So 2 times 0 is 0, and 0 plus b is just b. So it looks like my y-intercept is b. So now I have my slope of 2. -2. I have the slope of -2 and my y-intercept of 3. I can get my equation of y equals -2x plus 3. For number 32, what is the y-intercept for this equation? Well, I need to have it in general form, and general form says get the y by itself. So I'm going to do some upside down t's and get that y by itself. Now there's an 8x and a -4 on the same side as the y, so I need to get rid of the 8x first because it's being added because it's positive. So I would do an upside down t, and I would subtract 8x, which would give me a -8x on the other side, and I'm going to bring down my -12. The next step to get the y by itself would be to divide by -4. So -8 divided by -4 is a +2. -12 divided by -4 is a +3. So there's my equation in general form, but it's asking for the y-intercept. And the slope is 2, but the y-intercept is a +3. So my answer for the y-intercept is +3. Number 33, we are going to write this equation in general form, and general form again means get the y by itself. So the 9x and the +3 are on the same side as the y. I need to get rid of the 9x first because it is being added. So I would do an upside down t, and I would subtract 9x from the other side, which would give me a -9x with a +120. And next I would do an upside down t, and the opposite of multiplying by 3 is dividing by 3. And -9 divided by 3 is -3x. Plus, and 120 divided by 3 is 40. And this is my equation in general form. Number 34, solve this equation for the rate, which means get r by itself. The opposite of multiplying by t would be dividing by t, which would give me the r all by itself equals distance divided by time. So here's my equation solved for the rate. Number 35, we are solving this function for pi. So when I look over here at my equation, I just simply say, what's happening to pi? Well, it's getting multiplied by r squared. And the opposite of multiplying by r squared is dividing by r squared. So I get pi equals area divided by r squared. And this is my equation solved for pi. Number 36, what is the solution for this compound inequality? Well, since there's two symbols, I'm going to do a double upside down t. The opposite of multiplying by 5 is dividing everything by 5. So I get 3 is less than or equal to m, which is less than or equal to 9. So there's my answer. Number 37, we need a closed point at negative 32, which means b cannot be correct. And also d cannot be correct. So now we're down to a and c. X has to be bigger or equal to 32. Well, when I look up at A, they're shading left, and you're supposed to shade right. So A cannot be my answer. On C, they do have a closed point at negative 32, and they are shaded to the right, so let's look at the other side. X has to be smaller than 24 with a closed point. And C does have a closed point at 24, and they are shaded smaller, which is left. So C is the correct answer. Number 38, what is the solution to this inequality? I'm just going to solve this, and I see the distributive property first. 3 times 2 is 6. 3 times negative x is negative 3x is less than 18. I'm going to do an upside down t, and the opposite of adding 6 is subtracting 6, or opposite of a positive 6. And I get negative 3x. I do not flip my symbol yet because that was subtracting. And in the next step, the opposite of multiplying by negative 3 is dividing by negative 3, and I am dividing both sides by a negative, so I do have to flip my symbol, and I get x is greater than negative 4. Number 39, Bolorama offers his packages a flat fee of $24 for the room and $5 per person. So $24 for the room plus $5 per person, and Stella has $100 to spend. So I want the amount of money she spends to be less than or equal to 100, because if it's more, she can't afford it. So now that I've set up my inequality, I'm going to solve it, and the first thing I would do would be subtract 24, and I get 5p is less than or equal to 76. Next, I would divide by 5, and I get p is less than or equal to 15.2. So that means the people has to be less than or equal to 15.2. And the maximum number of people she can invite would be 15 people, because if she invites 16, that would cost her more than $100. Number 40, we are going to solve this for h, and that would mean doing an upside down t, and we have to remember the opposite of multiplying by a fraction is to multiply by its reciprocal, and the reciprocal would be 2 over 1 or just 2. So we get 2a equals bh. And then to get the h by itself, the opposite of multiplying by b is dividing by b. So when I divide by b, I get 2a over b equals h. For number 41, it says to just write the equations, or we do not have to solve it. So Samuel pays $46.99 plus 20 cents for each minute. So y is the total amount of money he pays. $46.99 plus 20 cents per minute, and I'm going to use x for minutes, over 450. Then Monica has to pay, again, y represents a total amount of money, $54.99 plus 10 cents per each minute over 450, and x represents a minute over 450. Number 42, solving the systems of equations. Right now we do not have opposites. So when I look, I see a positive 3x and a negative 9x. I would have to multiply this top one by 3 to get opposites. And that would give me 9x plus 9y equals 18. And then I scribble out my equation. Now I have opposites, so now I can do addition. The x's eliminate, and I get 4y equals 16. Divide, and we get y to equal 4. So in my answer, I know the y value has to be 4. Now we always go back and get the other variable, and I think the one that I scribbled out actually looks the easiest. So 3x plus 3y equals 6. Y is 4, so I'm going to plug a 4 in for my y. So 3x plus 3 times 4 is 12. From here, I would subtract 12, and I get 3x to equal a negative 6, and then I would divide by 3, and x equals a negative 2. So the answer is negative 2, 4. Number 43, how many solutions does this have? When you type this in on your calculator, you should hit zoom 6 or just hit graph. You should be looking at parallel lines. And since parallel lines never intersect, that means that there are no solutions to this problem. Number 44, a phone company has 2 long-distance calling plans. The first plan is $35 a month for unlimited distance calling. So my equation would be y equals $35 per month. The second plan is $10 per month plus 10 cents per minute. So that would be $10 a month plus 10 cents per minute. After how many minutes of long distance call will it be cheaper for a customer to purchase the first plan? Now I'm going to solve this one by graphing it on my calculator. Now you will probably have to adjust your window to make it much larger, and you should eventually get that they intersect at 250 minutes. 250 is how many minutes it would take for them to be equal, so more than 250 minutes is when it would be cheaper. For number 45, I went ahead and tried to color code the top inequality. I put in red, and second one blue, and the bottom one purple, so you can see they're matching lines below. So we are worried about the shading because all the graphs are exactly the same. So when I look at the top one, or the red one, it says y is smaller than x. So I need to find the one that is shaded below the red line. Well, A, it is shaded below the red line. B, it is shaded below the red line. C, it is also shaded, and so is D. They're all shaded below the red line. So now I'm going to move on to the blue line. The blue line says y is greater than. So since it says y is greater than, it has to be shaded above the blue line. Well, if you look at A, it is not shaded above the blue line, so it can't be A. B, it is shaded above the blue line, so it can still be B. C, it is also shaded above the blue line. But D, it is shaded below the blue line, so it can't be D. And then finally, I'm going to look up at the purple one. It says it has to be shaded above the purple line also, because it says y is greater than. So I'm going to look up here at B. B is not shaded above the purple. It's actually shaded below, so it can't be B. Down here at C, the shade area is above the purple line, so C is my correct answer. Number 46, write the inequality that represents the graph. Well, it is shaded above, and it's a dotted line, so y is greater than or equal to. I need to find the slope, so I'm going to zoom in and try to find me 2 points where it crosses perfectly on the graph. Well, I see right here the y-intercept, and if I keep going, it looks like it crosses perfectly right there, which would be up 3, so positive 3, and to the right 1, which means my slope reduces down to 3. So my slope is 3. My y-intercept, again, if I zoom in, it looks like it crosses right here at positive 1. So my slope is positive 1. Number 47, write the system of linear inequalities. Now I'm going to try to color code this as well. I'm going to use this line right here. I'm going to use it in red. It is a solid line and it's shaded below, so I'm going to say less than or equal to. The slope, if I zoom in, it looks like it crosses perfectly here and here. And to do that, it looks like it goes up 2 and to the right 1. So up 2 and to the right 1 would give me a slope of 2 over 1, which reduces to 2. So my slope is 2. The y-intercept, it crosses right here at negative 1. So my y-intercept is negative 1. Now I'm going to do the other line, and I'm going to do that one in purple. It is shaded above, and it's dotted, so I just put a greater than symbol. The slope, let's find 2 points where it crosses perfectly, here and here. It looks like it's going down 2 and to the right 1. Well, down 2 is negative 1, and to the right 1 is positive 1. That reduces to negative 2. So the slope of the purple line is negative 2. The y-intercept looks like it crosses right here at positive 3. So my y-intercept is positive 3. Number 48, which is a solution for this system of linear inequalities? To solve this, we need to take every point A, B, C, and D and plug them in both the red and the purple inequalities and see which ones work. So I'm going to start with A. 2 is my x and 1 is my y. So when I plug them in, I get 1 equals 3 times 2 plus 5. 3 times 2 is 6 plus 5 is 11. And then I ask myself, is 1 bigger than 11? No, it is not. So A didn't even work for the first inequality, so it can't be my solution. So then I go on to B. I'm going to erase this real quick. And again, B, 3 is my x and negative 4 is my y. So negative 4 is greater than 3 times 3 plus 5. 3 times 3 plus 5 is 9 plus 5, which is 13. Is negative 4 bigger than 13? No. So B didn't work for the red inequality either, so B can't be my answer. So now I'm going to go on to C. Part C, negative 1 is my x and 0 is my y. So 3 times negative 1 plus 5. 3 times negative 1 is negative 3 plus 5 is positive 2. Is 0 bigger than 2? No, it is not. So C didn't even work for the first one either. So now let's check and make sure D is actually my answer and I didn't make any mistakes. So now I'm going to try the last one. 5 is greater than 3 times negative 5 plus 5. 3 times negative 5 is negative 15 plus 5 is negative 10. So 5 is bigger than negative 10. So it passed the first inequality. Now let's try it on the other one. 5 is less than negative 3 times negative 5 plus 6. 5 is less than negative 3 times negative 5 is positive 15 plus 6 is 21. And is 5 smaller than 21? Yes, it is. So the point negative 5, 5 does work for both the red and the purple inequalities. So D is my answer.